Hello everyone, my name is Rahul. I'm from the Institute of Technology, and I have taken a microprocessor called RX231 of RENESAS. Here I'm going to show a block diagram of the microprocessor which I have drawn. This is the block diagram of the microprocessor, and the source where I have drawn is the source where I have drawn is diagram. Here is a block diagram where I have drawn it. And the next thing is about the instruction set of the microprocessor of RENESAS RX231. Here is the instruction set. There are a total of 6 instructions, and they are divided into arithmetic logic instruction, which has floating point operating instructions, data transfer instructions, and bit manipulation instruction, string manipulation instruction, etc. And here I am explaining about the microprocessing element. The microcontroller RX231 is based and designed on CIS hardware architecture with 5-stage pipeline. It is of a low power design, and architecture is explained following as well. It is capable of operating on the battery backup power is supplied, 3 low power consumption modes, etc. And the next thing I'm going to show you is about how to correlate the microprocessing element architecture with architecture discussed in module 1. The main architecture we discussed in module 1 of COA, Virch, Harvard, and Newman architecture, and also about CISC and RISC architectures. Here the MCU RX231 is based and built up mainly on the Harvard architecture and CISC architecture, correlating them. Next thing we are going to discuss about the elaborate register organization of microprocessing element. There are 2 types. One is general purpose registers and control registers. Important points to be noticed is exception stable register, interrupt table register, program counter, process status control, backup PC, backup D register, review, and fast interrupt vector register. Floating point status work. That's it. And this is the whole thing of what I did about this DA1, that is still a semi-con, with the help of our professor Dhanbad. And we are going to discuss about the type of algorithm used for signed to answer calculations. It is generally the booth algorithm is a procedure for multiplying binary integers in science designed to complement the design efficiently. So, for unsigned calculations, this is the block diagram to which I have drawn. As in all multiplication schemes, both algorithm requires examination of the multiplier bits and shifting of the partial product. We have to shifting and multiplying by grabbing to the partial product subtracted from the partial product or left unchanged according to the following rules. The multiplying is subtracted from the partial product upon encountering the first least significant one in its range of ones in the multiplier, and the multiplicand is added to the partial product upon encountering the first zero from the return there is a previous one in a string or zeros in the multiplier. And this is the following block diagram, the way which I explained. Next one, we are going to discuss about the type of control logic unit used and correlate its performance with type of control unit in Module 3 in COM syllabus. So the microprocessor RX231 has a 32-bit RX-V2 CPU core max operating frequency 54 MHz, capable of 88.56 DMIPS in version 54 MHz, enhanced DSP 32-bit multiplier output unit and 16-bit multiplier instructions support built-in FPU 32-bit single precision floating point, compliant to IEEE 754. The control unit is a digital circuitry contained within the processor or that coordinates the sequence of data movements into out of and between a processor's many subunits. The result of these routed data movements through various digital circuits within the processor uses the manipulated data expected values of the instruction and controlled state of flow inside the processor, and additionally provides other external control signals to the rest of the computer to further the activity. And the next thing is it consists of one or more micro operations to be executed. The information about the micro instruction to be executed next, and so on. Micro instruction execution primarily involves the generation of desired control signals and signals used to command the next micro instruction to be executed. It also issues a read command to control unit. Control unit configures the data path operation sequence of desired operations stored in memory. Program instruction cycle broken into several sub operations, each one clock cycle. And the next thing we are going to discuss about the memory management system and the processing element selected list, its addressing capabilities, memory mapping technique, followed. Memory and the advantages are listed below. ROM, which is read-only memory, has a capacity of 128 or 256 or 384 or 512 kilobytes, up to 32 megahertz no weight memory access and programming or erasing method, serial programming or self-programming. RAM, which is also known as random access memory, which has capacity of 32 to 64 bytes, 54 megahertz no weight memory access, and E2 data place capacity 8 kilobytes, number of letters, etc. These requirements of memory management are relocation, protection, sharing, logical organization, physical organization. That's it. And next thing we are going to discuss is about the pipeline and parallel processing capabilities of the unit and the hazard management technique in my RX231 microprocessor. First stage pipeline is used. First stage pipeline during normal operation, one instruction is being fetched from memory, the previous instruction is being decoded, the instruction before that is being executed, the instruction before that is performing data access, the instruction before that is writing its data back to the register bank. These are situations called hazards that prevent the next instruction and the instruction stream from being executed during its designated clock cycle. Hazards reduce the performance from the ideal speed of gain by 5 more. There are three classes of hazards which are called structural hazards, data hazards, and control hazards. The next thing we are going to discuss is about the find whether processor level parallelism is available in the element select, and illustrate cache coherence and protocol used for handling memory, HIT or MISs. Processor level parallelism. To get a 50, 100 or more, the only way is to design computers with multiple CPUs. We will consider three alternative architectures: array computers, multiprocessors, and multi-computers. Array computers. An array processor consists of a large number of identical processors that perform the same sequence of instructions on different sets of data. A vector processor is efficient at executing a sequence of operations on pairs of data elements. All of the additional operations are performed in a single heavily pipeline adder. That's it. This is what I did about my visual assignment by taking the microprocessor of RENESAS. Thank you.